Hello everyone and welcome to a new video. In the last video you saw that I just configured the OSPF in the data center and also add some authentication between R8 and R9. I just if you remember, I promised to configure the EIGRP in these three sites in the next video, but I just received some messages from my friends and they asked me to speak more about the OSPF authentication and also about the OSPF cost to traffic engineering inside the OSPF domain. For that, first let's uh, go to the authentication. We don't have anything in the authentication, but I'm going to enable the authentication in the OSPF process. Let me tell you first that we have two types of authentication, the plain text and the message digest. And we can enable these two types of authentication in the link basis or in the all OSPF process domain. For example, in the last video, we enabled the authentication between R8 and R9 in this link and use message digest. But today, I'm just going to enable the authentication in the OSPF domain and then configure the other routers to use the same authentication to communicate. Now, for that, let's start from switch 4. In the switch for enabling the authentication to the OSPF domain, we need to go to the OSPF process. Router OSPF 1, then the authentication is based on the area. We can select area 0, authentication. Now we have two options here. We can press enter. By pressing enter, we will configure our router to use the plain text authentication, but by selecting the message digest, I just configure the router to use authentication using MD5. Okay, now the authentication is enabled in the area 0 and all these three routers, actually these two routers and this one switch, will be disconnected in a minute because they don't have the authentication inside the area 0 domain. And let's wait for that. And in meantime, let me go to switch 4 also. Let me bring this, let me open all of this and then bring them on the screen. Switch 5 and switch 5, 4 and 5. Okay. You can see that the time expired between router 8 and switch 4 in VLAN 20 and VLAN 10. Now we all all the domain is disconnected and we don't have any neighbor here. Do show IP OSPF neighbor and we don't have any neighbor here. And because I just enabled the authentication in switch 4. Now for the rest of the configuration, we need to enable the authentication to the interfaces. For that, let me select interface range, VLAN 10, VLAN 20, VLAN 8, and loopback 0, and IP OSPF message digest key. And now we can select the key ID from 1 to 255 and then select the MD5, and at the end we can select a password. Now all the interfaces in R4 is configured to use the authentication. Let's using the message digest, let's enable the authentication in switch 5 in the area 0. Conft router OSPF 1 area 0 authentication message digest. Now the message digest is enabled and we need to enable the you can see we don't have valid key for authentication. If we don't enable key, and this router will never be connected. Let's add a key to the interfaces. Interface range, VLAN 10, VLAN 20, VLAN 9 in this case, and it was VLAN 8 and this VLAN 9, and then give back 0. Then IP OSPF message digest, key 1, MD5, and the keys Cisco. Now these two routers, these two switch should bring up the OSPF process. Yes, it's up in VLAN 10 and also in VLAN 20. Now let's configure that in these two routers also. VLAN 0 authentication message digest, and let's copy this. I want to make everything very fast. OSPF1, and this is the command. Let's go to interface range. Provide 0 is 01 to 2. IP OSPF message digest, key 1, MD5, and the keys Cisco, and let's go to the same interfaces in this router and enable this here. Okay, now you see the with switch 4 the neighbor is come up. Here also with switch 5 it come up. Let's wait between the R9 and R8, but let me check because we already have one authentication here. Let me see if it's still under effect. To show interface A02. Yes, we have two authentication here, and do show IP OSPF neighbor. And yes, there is no problem. Actually, it's supporting. It's a good example. It's supporting two type of authentication, one in area and one in the interface basis, and there is no problem. These two routers are neighbor, and we don't face any problem here. Okay, this is all about authentication. We don't have anything more. It's very simple. And next part of this video, let's do some traffic engineering. For the traffic engineering, actually, before I said one of the feature of OSPF is the traffic engineering using the cost. And before that, let me show you this page. We have different interfaces here. You can see the 10 megabit, and the default OSPF cost for this interfaces is here. You can see for 10 megabit we have 100, and for 100 megabits we have 10. And when the cost is less, it means that path will be preferred for the route. Actually, let me remind something. This changing the cost inside the interface doesn't affect anything in the bandwidth. It's just for the OSPF to select the path. And now we are just connected with the 100 megabit Ethernet. Then our cost is 10 in all these interfaces. For verifying that, let me see. Let's see show IP OSPF interface E0, for example 1. For E01 you see that the cost is 10. And for all virtual interfaces like VLAN and loopback, the cost is 1. Do show IP OSPF interface, for example loopback 0. You see the cost is 1, and also for VLAN 10 the cost is 1. And if we verify the route, let's try to trace from R9 to loopback interface or switch 4, because we have two paths, one path here and one path here. Let's see which path it's going to select. 10, 10, 10, 104. I'm going to ping it trace it numerically to make it fast. Actually, if we don't use numeric, it's going to find the name of this IP address, and it's going to DNS, and it takes a long time to show us this result. And now you see it's going through 517. It means this VLAN 9 here, do show run interface VLAN 9. Yes, this is the 17. It means the route is going through this path, not this path. And it's going to load balance between VLAN 20 and VLAN 10. If we see the cost of this route, show IP route 10, 10, 10, 104, you can see the route metric for this is 12. Why it's 12? I show you that we have a 10 here, and in the VLAN we have cost of 1, and when we come here we are going to loopback 0, and then we have a cost of 1 in loopback 0, then 10 plus 1 plus 1 will be 12. And if we check the route for switch 5, you can see it's 11. It's because of 10 here, and 1 in VLAN 1 or in VLAN 10 to go to loopback 0. Then we have the cost of 11 here. For traffic engineering, actually we can do two things. We can increase this cost of this link, or we can decrease the cost of this link. For this one, I believe if we increase this cost, it will be less configuration, because increasing this cost, it's become for example, if we put it in 1, and this 1 plus 10 become 11, and then 1 we have a 12 here, and these two paths will have the same cost. Okay, let's do it and see what will happen, because it should show both path here. Now for this route, let me clear the screen. For this route we only have one path, and if I change the cost on Ethernet 02, interface is 02, IP OSPF cost, for example, put it to 1, and check do show IP route 10, 10, 10, 104. Yes, you can see now we have two paths for that. Even this the first path is still preferred. This star shows that this path is preferred, and not preferred, it's already used, because maybe because this route was already available in the table, and the router doesn't want to update this the routing table. It's belong to the OSPF. And now you can see that we have two paths for this route. Okay, let's remove this cost here and change the cost in E02 and make it higher than 10. Interface E01 and IP OSPF cost, for example, 100. If I make it 100, it means 100 plus 1 plus 1 is with 102, and in this case we have 10 plus 10, it's become 20, and 1 here, 21. Then this path should be preferred, and if we check it, do show IP route 10, 10, 10, 104. Yes, you can see that this time is just one route is shown here, and the metric of that is 21. This is 10, this path is 10, this path is 10, 20, and 1 for VLAN 1 to go to loopback 0. Then our metric is 21. We just prefer this, and this is actually everything in traffic engineering. It's depend to us. Now our network is very small network, and we cannot do any adjustment here, but in the very large networks It depends to the requirement. We can engineering the traffic between the routers to prefer one path instead of another path. It depends to the router model. If we have a very powerful router and we want to send all our traffic to one router, we can using cost to engineering the traffic in the OSPF domain. Okay, I don't want to continue anymore. Just let's finish our video here. Thank you for your watching, and I hope see you in the next video by configuring the EIGRP in these 3 sites. Please follow our channel, the Network Fun, to have a lot of fun in the configuration of the network. Thank you for your watching, and see you in the next video.